Hello everyone, welcome to Old School Chemistry. Today we're going to do the ALEKS topic, calculating the heat of reaction from molar reaction enthalpy. Let's go ahead and look at this question. There are a couple of things I want to highlight. So it says a chemist measures the energy change, delta H, that's enthalpy, during the following reaction. So they give us a balanced chemical equation. What I want to highlight, two things. Watch those molar coefficients. This enthalpy, the delta H, the heat of reaction, very, very technically is kilojoules per mole of reaction. And I so wish Alex would have typed that in here. I'm sorry. When you see this, I want you to rewrite it. Delta H equals negative 2,220 kilojoules, watch this, per mole of reaction. Per mole of reaction. That's what it is by definition. Delta H is a state function, and it's always a ratio per mole, per amount of substance. So what you can draw from this, putting together the molar ratios and our enthalpy, is every single molar ratio, every single mole of our coefficient for each compound, that tells you how much energy, in this case, because it's negative, will be released. If you completely react 1 mole of our, let's see, this would be a propane gas, is going to release 2,220 kilojoules. If you completely react exactly 5 moles of oxygen, it will release 2,220 kilojoules. Likewise, if you produce exactly 3 moles of carbon dioxide, that is going to release the 2,220 kilojoules. And same thing with the 4 moles of water, it will produce the 2,220 kilojoules. Now that's going to be really important because we have to use that ratio to do a conversion, to go from grams to energy. That is so neat. Look at this, just 1 second. This is going from amount of substance, moles, to energy. We have a bridge to go from substance to energy. I think that is so neat. Okay, let's pull this all together. I'll show you how it works. So it says first this reaction is, I want to remind you, endothermic means it absorbs energy. I tell my students think of enter, E-N, endo. This is going to be a positive sign. And then exothermic, that is energy is released from the system. And so exo, I tell my students think exit, like exo, EX. And this is a negative sign. So super easy, you just look at the sign. If there's no sign, it's understood to be positive. So here I have my negative, easy peasy. I'm going to write down that is exothermic. It is releasing energy. And absolutely, we know that combustion releases a lot of energy. Okay, so they tell us, hey, you have 18.1 grams of this propane. Will any heat be released? Absolutely, yes. Because it's exothermic, it will be released. If it was endothermic, I would mark absorbed. So those first two questions are really easy. You just look at the sign and you immediately have your answer. Exothermic, released, endothermic, absorbed. Now the math part. It says, if you said heat will be released or absorbed, which it always will be in this question, in the second part of the question, calculate how much heat will be released. Here's the math. How much heat will be released? You always begin with what you're given. So we're going to start with our 18.1 grams of the propane. Now here's the deal. To walk the bridge, to go from moles to energy, and that's what we want, right? We want kilojoules. That means I have to bring grams to moles. I say this 1,000 times in my class. Bring it to moles, bring it to moles. So let's bring this to moles. Grams will go in the denominator, so it cancels. I want moles. Now, by definition on our molar mass, 1 mole always has a certain number of grams, and that comes from the periodic table. So let's add this up. We've got 3 carbons. The molar mass is 12.01, gives us 36.03. We've got 8 hydrogens. That's 1.01, gives you 8.08, and that is going to give us 44.11 when you add that up. Remember, 44.11 grams per mole. When you have 1 mole of propane, it weighs 44.11 grams. Great. So we went from from grams of our propane to moles of our propane. Now we can use this. Okay, be so careful. I have to pull back in my molar coefficients here. So if I want to get rid of moles of propane and end with kilojoules, we'll come up here and look at our chemical equation. I go, I see it. 1 mole of propane is going to release the negative 2,220 kilojoules. Now on this, just pretend with me, okay, just pretend. Pretend that they had said, hey, how much energy would be released if you had 18 grams of carbon dioxide produced? If it had been carbon dioxide, what would I have changed over here? Think about that. If it had been carbon dioxide, what would have changed? It's the 3 moles. I would have put 3 moles of CO2 releases the 2220. If they had said water, I would have put 4 moles down here. If they had said oxygen, I would have put 5 moles down here. Whatever that molar coefficient is, whatever that coefficient is, that's what you attach for the moles of the substance, either producing or releasing the energy. That's why mole of reaction is so important. That tells us it relates back to the chemical reaction, the molar ratio of all of those coefficients. So be careful on that. I'm sorry they didn't type it, but now you know. I'm just going to make it easy for you. Okay, let's put this into our calculator, see what we get. So we will have the 18.1 grams divided by 44.11 grams times the negative 2,220 kilojoules. Oh, I put one too many too. Let's see, 0. And we end up with negative 910.9. I'm going to pause. Started with 3 sig figs. We have 4 sig figs here. That means I'll have 3 sig figs, 1, 2, 3. Look at the bossy number. It says round up. So my final answer, 911 kilojoules will be released. And I'm going to put my negative right there. Okay, so on this, it says how much heat will be released or absorbed. That means they just want magnitude. You don't have to put the negative on it. I'm just going to do the 911. Let's see, exo release 911. Put your decimal, always appropriate to put the decimal, just confirming, hey, I did the sig figs. Let's go ahead and check it, just because it's gratifying getting that correct. Okay, well done. Super proud of you. Watch this again if you need to process it just a little bit more. Please like and subscribe if you haven't already, and I'll see you next time. Thank you.